Hi, I'm Sanjay Paul, and our team is Green Team. Actually, Professor has given a task, assignment 3, which is about the land cover statistic of Texas state. Here we use the clipped data for Texas state. And in this project assignment, our objective is graphical representation of various land to distribution the planted area, which is shown in a bar chart. And our second objective is the check the land area of Texas using land use map, and classifying the land use map into four different types of area, which is previousness or feature, and estimating the area of impervious land. And here we can see that some sources where we get the information and of for the code. And after that we input the library over here in GDAL, and we import numpy as np, and then we import the image file using GDAL for open the function. And here we can see the raster data equals to GDAL, and the image for the saved variable of raster. And then reading for reading the image, we create a array which is np array, and then we import matplotlib library to graphical plots for the visualization. And we can see that here the map, which is actually 44,254 in x direction, and 41,260 in the y direction. This is the pixel. And then after that we create a unique array to see what is in the image. And from this we find some numbers which represents the color of the image. And here we're defining some variable, and we took this variable from this table, mrlc table. And here we define the all variable over here. Then we convert the square, we use a conversion factor. We convert square meter to square mile, and our each grid in this image, each grid in each grid size is 30 meter to 30 meter, which is the percentage of the gray of background in the image. And we can see the background over here. Then the next part will describe by my another teammate Dharmik Patel. Thank you.
Hello, we are working on assignment 2 given by our professor. Our objectives are like graphical representation of land use distribution per planted area, and by given a bar chart, and that we are going to check the land areas of Texas using land use map, and we are also classifying land use map into 4 different types of areas by perviousness feature, and also we are going to classify it. And the least but the last, would be estimating the area of impervious land. So one of my group member described the how, what he did. So here we are going to defining the variables to count the number of pixels having various color codes. So we define the different types of land uses, like the black portion in the background. It shows like whole area 1 - 128, that shows a black color. And we are going to subtract the Texas area. So we are going to define it by the area that is not in that of that color, like -121. The rest of the area, it could be like of Texas. The other areas, like for 0, we define for 0. For water, it's 11. For developed area, we can find it from the on a website or named MRLC. That's a National Land Cover Database, class, legend, and description. So at the same for the other land use types, we are going to define the colors for different type of land uses. And then we put a conversion factor to convert square meter to square mile, because we need the area for in a mile. And then we are going to define the area of Texas. So it will give the percentage of gray background in the image. And then we are going to print all the area that will be in the outcome in terms of percentages. So it will give you output like this, like that. In the picture, the gray background is blank percentage of total image area. The same for the other definitions, other terms. So then we are going to make a list that includes the all type of land uses from 0, barren, forest, etc., up to wetland. Okay. Then we are going to converting list into NumPy array, so that we can run an array and plot an image from that. So we are going to convert pixel count to area for all land use variables by y underscore area using multiply command. We are going to define a 30 is 30 into 30 because of the the size of the pixel. We are assuming it as a 30 meter by 30 meter. So, and then we are going to create a label for getting for plotting the image. Then each type of land use paired with the area in square miles. So we are going to print all types of headings, like a legend, area, square mile. So it will print the all type of land uses with the outcome of already by default converted area into square mile. So, and then we will head towards to plot the bar graph of land use into the ratio to planted area. So, and we will have outcome like it shows the bar chart. We can find it like shrubland. They are having a higher area ratio with respect to cultivated area, and we are showing is this only for land use versus area ratio with respect to cultivated area. We may define with respect to other terms as well, but we are going to define is this way because we are asked to do that. Okay, thank you, sir. The onwards, our
Hi, I'm Awaz Gautam, and we are from Green Group. And moving further into our assignment 3, what we have next is plot of pie chart. It is simply to visualize the land use percentage of different kind of land use, like Sorb has 40.9%, Herbland 14.4%, and so on. And then we have our own classification. The main objective is to classify the different land use that's already there and come up with a different kind of classification, as blue zone, green zone, red zone, and gray zone. In blue zone we have like water dominant areas like open water, and then watersheds, wetlands, sorry. And then for green area we especially have the areas that are dominant with plants, like heartland, shrubland, all those are in green areas, or green zones. And for by red zones we mean like the developed city and towns are included in red zone, and by gray zone we mean to say the barren land. And then since we have pretty much calculated the number of pixels in all the zones already, now we just add them up to make blue zone, green zone, red zone, and gray zone, and create a list out of them, and then convert that to numpy array and feed them via matplotlib to generate pie chart as shown. Now we have the Greenland is like 87.8%, followed by followed by red and green. They are almost equal with 5.9%. And then we had another our objective that we had is to estimate the tentative impervious land. When you go and look at the website and the legend, when we go through the legend, we saw that they have of mathematical figures like which indicate the tentative percentage of impervious land for each features. So we use this to estimate the area of impervious land, since we have for less than 21 we have less than 20%, for less than 22 20 to 49%, and so on. So we come up with a value. For less than 20 we use 19, and for all others we used average values. So we use these percentage to calculate the total impervious area in Texas. It's not actually calculate, it's an estimate. It's change the data, or the read the data and come suggest some values that could be useful, like some there could be some research or something that could actually use or do something with the impervious area, land area in Texas. So that's our calculation right here, and which is like 6290.61 square miles. And then what we tried next is to whatever our classification is, we wanted to reflect them in the map. So we have assigned the values. We chose one values for red color among 20, 21, 22, 23. For blue we did the same thing, we chose 11, and for green area we did the same thing and chose number 42. So we converted all the area to number 42 for green. For the blue we did same, converting to 11, and for the red we did same, converting to 21. And this is our new plot that we wanted to show our classification on the map. So to conclude, in this way we answered our objective that we said at the starting of this video, and then eventually we come up with a map that that has our own little classification by the name of colors. Thank you so much. This is Awaz Gautam from Green Group.